Welcome to qnawire.
Okay, we have a substituted cyclohexane with a dashed CH3 and a wedged hydrogen, a wedge to H3C, that's a methyl group, and a dash to bromine. And we are reacting it with sodium T-butoxide, and we're doing this reaction in DMF, dimethylformamide. The question is, what is the mechanism type? E1, SN1, E2, or SN2? And then we need to draw the major product. We'll note that our leaving group, bromine, is on a tertiary center, which means this cannot be, by definition, SN2. SN2 is off the board. This only works with secondary or primary substrates. Next, we can look at our reactant. This is sodium T-butoxide. This is a bulky base. And it is a strong bulky base because it is charged. Likewise, because it is so bulky, that makes it a weak nucleophile. If it is a weak nucleophile and a stronger base than nucleophile, then it will not be substitution. It will be elimination, because the elimination pathway with a strong base is much more favorable to any substitution with a weak nucleophile. Furthermore, since it is a strong base, it will not be E1, but rather E2, right? E1 is typically what happens when you have, say, a weak base that's non-nucleophilic, but if you have a strong base, that's going to favor E2, the concerted reaction. Okay, now that we've established that, we need to identify what the major product does. If we go through E2 reaction, then we know that we're talking about one of the hydrogens on a neighboring carbon, which is anti to the bromine, a necessary requirement for E2, will be picked up by the oxygen. The carbon-hydrogen bond will be left behind as a double bond, and bromine will leave, generating cyclohexene with a double bond between these two carbons. Everything over here will remain the same, but we will now have a planar carbon. Therefore, this methyl group will no longer be on a wedge, and this will be our product.